Hello friend, welcome to Krishna Foundation. As per discussion, we have started the new segment that is Audio Library. So in this library, you can get or enjoy the listening of chapters of the entire syllabus of SST and Science. So today we are going to see the chapter first, chemical reaction and equation. Consider the following situation of daily life and think what happens when milk is left at room temperature during summer. Second, an iron tawa, pan or nail is left exposed to humid atmosphere. Third, grapes get fermented. Fourth, food is cooked. Fifth, food get digested in our body. Sixth, we respire. In all the above situation, the nature and the identity of the initial substance have somewhat changed. We have already learned that about physical and chemical changes of matter in our previous classes. Whenever a chemical changes occur, we can say that chemical reaction takes place. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer these questions. Activity 1.1. Caution. This activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. Clean a magnesium ribbon about 3 to 4 cm long by rubbing it with the sandpaper. Hold it with a pair of tongs, burn it using a spirit lamp or burner, and collect the ash so formed in a watch glass as shown in figure 1.1. Burn the magnesium ribbon, keeping it away far as possible from your eyes. What do you observe? You must have observed that magnesium ribbon burns with a dazzling white flame and changes into the white powder. This powder is magnesium oxide. It is formed due to the reaction between the magnesium and oxygen present in the air. Activity 1.2. Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe? Activity 1.3. Take a few zinc granule in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this. Caution. Handle the acid with care. Remember student, handle the acid with care. Do you observe anything happening around the zinc granule? Touch the conical flask or test tube. Is there any change in its temperature? From the above three activities, we can say that any of the following observations help us to determine whether a chemical reaction has taken place. Change in state, change in color, evolution of gas, change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reaction taking place around us. We will study about various types of chemical reaction and their symbolic representation in this chapter. Point number 1.1. Chemical equations. Activity 1.1 can be described as when a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. When a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence forms is quite long. It can be written in the shorter form. The simplest way to do this is to write it in the form of word equation. A word equation for the above reaction would be magnesium plus oxygen reaction takes place yields magnesium oxide. The substance that undergoes chemical change in reaction, that is magnesium and oxygen, are reactant. So here we can get the simple definition of reactant. The substances that undergoes chemical change in the reaction are called reactant. The new substance is magnesium oxide formed during the reaction as a product. Or simple we can say here, the new definition student, the new substances is formed during reaction is called a product. A word equation shows change of reactant to product through an arrow placed between them. The reactant are written on left hand side with the sign plus between them. Similarly, the product are written on the right hand side with plus sign between them. The arrow ahead points toward the product and shows the direction of the reaction. Next point, 1.1.1, writing a chemical equation. Is there any other shorter way to representing the chemical equation? Chemical equation can be made more concise and useful if we use chemical formula instead of word. A chemical equation represents a chemical reaction. If you recall formulas of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 reaction takes place MgO. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on the both sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on the both sides of equation. Such equation is skeletal chemical equation for reaction. Remember this point student. Such equation is called or skeletal chemical equation for reaction. So skeletal chemical equation is nothing but the we can say unbalanced equation. Equation 1.1 is a skeletal chemical equation for burning the magnesium in air. Next point, balanced chemical equation. Recall the law of conservation of mass that you have studied in class 9. Mass can neither be created nor destroyed in chemical reaction. That is, the total mass of element present in the product of chemical reaction has to be equal to the total mass of elements present in reactants. In other words, the number of atoms of each element remains same before and after the chemical reactions. Hence, we need to balance a skeletal chemical equation. Is the chemical equation balanced? Let us learn about balancing a chemical equation step by step. The word equation for activity 1.3 may be represented as zinc plus sulfuric acid reaction takes place zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical equation: Zn plus H2SO4 reaction takes place ZnSO4 plus H2. Let us examine the number of atoms of a different element on both sides of the arrow. As the number of atoms of each element is the same on the both sides of arrow, then it is balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2O reaction takes place Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw a box around each formula and do not change anything inside the box while balancing the equation. Step 2. List the number of atoms of a different element present in the unbalanced equation. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be the reactant or product. In that compound, select element which has maximum number of atoms. Using these criteria, we'll select Fe3O4 and the element oxygen in it. There are four oxygen atoms on the right RHS, that is right hand side, and only one on the LHS. To balance the oxygen atom, to equalize the number of atoms, it must be remembered that we cannot alter the formula of compound or element involved in the reaction. For example, to balance oxygen atom, we can put coefficient 4 as 4H2O, not H2O4 or H2O whole bracket 4. Now, partially balanced equation become Fe plus 4H2O, reaction takes place Fe3O4. Now, the partially balanced equation become Fe plus 4H2O, reaction takes place Fe3O4 plus H2. Step 4. Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atom in the partially balanced equation. To equalize the number of H atom, make the number of molecule of hydrogen as 4 on the RHS. The equation would be Fe plus 4H2O, reaction takes place Fe3O4 plus 4H2. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. To equalize Fe, we take 3 atoms of Fe on LHS. 3Fe plus 4H2O, reaction takes place Fe3O4 plus 4H2. Step 6. Finally, to check the correctness of balance equation, we count atom of each element on both sides of the equation. 3Fe plus 4H2O, reaction takes place Fe3O4 plus 4H2. The number of atoms of elements on the both sides of equation are equal. This equation is now balanced. This method of balancing chemical equation is called heat and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbol of physical state. Carefully examine the above balance equation. Does this equation tell us anything about physical state of each reactant and product? No. Information has been given in this equation about their physical state. To make the chemical equation more informative, the physical state of reactant and product are mentioned along with their chemical formula. The gaseous, liquid, aqueous, solid state of the reactant and product are represented by the notation small g, L, AQ and S respectively. The word equation AQ The word aqueous in bracket AQ is written if the reactant or product is present as a solution in water. So the balance equation is 3FeS plus 4H2O in bracket G. Reaction takes place Fe3O4 in bracket S plus 4H2O in bracket G. Note that the symbol of G is used with the H2O to indicate that in this reaction water is used in the form of steam. Usually physical states are not included in the chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reactions are indicated above and or below the arrow in the equation. For example, CO plus 2H2O reaction takes place 340 atm CH3OH. Second equation, 6CO2 plus 12H2O reaction takes place with conditions sunlight and chlorophyll. CH6H12O6 plus 6O2 plus 6H2O. Using these steps, can you balance the equation 1.2 given in the text earlier? 1.2 Type of chemical reaction. We have learned in class 9 that during the chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appears from elsewhere. Actually, chemical reaction involves breaking and making of bonds between atoms to produce new substance. Remember this point, student. Chemical reaction involves the breaking and making of bonds between atoms to produce new substances. You will study about the type of bond formed between atoms in chapter 3 and 4. First type, combination reaction. Activity 1.4. Take small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown in figure 1.3. Do you feel any change in temperature? Calcium oxide reacts vigorously with the water to produce slake lime, that is calcium hydroxide, releasing a large amount of heat. CaO plus H2O reaction takes place CaOH2 plus heat. In this reaction, calcium oxide and water combine to form single product calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as combination reaction. Remember this point, student. In this reaction, calcium oxide and water combine to form a single product. So, a reaction in which a single product is formed from two or more reactants is known as combination reaction. Do you know? A solution of slake lime produced by the reaction is used for whitewashing walls. Calcium hydroxide reacts slowly Do you know? A solution of slake lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that chemical formula for marble is also CaCO3. Let us discuss some more example of combination reaction. Burning of coal, C plus O2 reaction takes place CO2. Formation of water from H2 gas and oxygen gas. Twice H2 plus O2 reaction takes place twice H2O. In simple language, we can say that when two or more substances, element or compound combine to form a single product, the reaction are called combination reaction. Remember this point, student. Combination reaction. In simple language, we can say that when two or more substances, that is element or compound, combine to form a single product, the reaction are called combination reaction. In activity 1.4, we also observe that large amount of heat is evolved. This makes the reaction mixture warm. Reaction in which heat is released along with the formation of product are called exothermic reaction. Here the definition of exothermic is also given. So what is the definition of exothermic? Reaction in which heat release along with the formation of products are called exothermic chemical reaction. Other example of exothermic reactions are burning of natural gas. CH4 plus twice O2 reaction takes place CO2 plus twice H2O. Do you know that respiration is exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potato and bread contains carbohydrate. These carbohydrates are broken down to form glucose. These glucose combines with oxygen in the cell of our body and provide energy. The special name of this reaction is respiration. The process which will you study in chapter 6. Equation is given C6H12O6, that is glucose, plus 6O2 reaction takes place CO2 plus 6H2O plus energy. The decomposition of vegetable matter into compost is also an example of exothermic reaction. Identify the type of reaction taking place in activity 1.1 where heat is given out along with the formation of single product. 1.2 Decomposition reaction. Activity 1.5. Take about 2 grams of ferrous sulfate crystal in dry boiling tube. Note the color of ferrous sulfate crystals. Heat the boiling tube over the flame of a burner or spirit lamp as shown in the figure 1.4. Observe the color of crystal after heating. Have you noticed that green color of ferrous sulfate crystal has changed? You can also smell the characteristic odor of burning sulfur. 2FeSO4 reaction takes place with condition of heat. Fe2O3 plus SO2 plus SO3. In this reaction, you can observe that a single reactant breaks down to give the simple product. This is decomposition reaction. Remember student this point, decomposition reaction. In this reaction, you can observe that a single reactant breaks down to give simpler product. This is a decomposition reaction. Ferrous sulfate crystal lose water when heated. The color of crystal changes. It then decomposes to the ferric oxide Fe2O3 and sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is a solid while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacturing of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. When a decomposition, remember this point also, when a decomposition reaction is carried out by heating, then it is called thermal decomposition. CaCO3 carried out by heat, CaO plus CO2. Another example of thermal decomposition reaction is given in activity 1.6. Activity 1.6. Take about 2 gram lead nitrate powder in boiling tube. Hold the boiling tube with the pair of tongs and heat it over a flame, as shown in the figure 1.5. What do you observe? Note down the change, if any. You will observe the emission of brown fume. These fumes are of nitrogen dioxide, that is NO2. The reaction that takes place is twice Pb NO3 twice. Reaction takes place with condition of heat, twice PbO plus 4NO2 plus O2. Let us perform some more decomposition reaction as given in activity 1.7 and 1.8. Activity 1.7. Take a plastic mug, drill 2 holes at its base and fit rubber stopper in these holes. Insert carbon electrode in these rubber stopper as shown in figure 1.6. Connect these electrodes to the 6-volt battery. Fill the mug with the water such that electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with the water and invert them over 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at the both electrodes. These bubbles displace water in the test tube. Is the volume of gas collected in the same in both test tubes? Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by one by bringing a burning candle close to the mouth of test tube. Caution: this step must be performed carefully by the teacher. What happened in each case? Which gas is present in each test tube? Activity 1.8. Take about 2 gram of silver chloride in china dish. What is its color? Place this china dish in sunlight for some time. Observe the color of silver chloride after some time. You will see that white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Twice AgCl reaction takes place with the condition of sunlight, twice Ag plus Cl2. Silver bromide also behave in the same way, twice AgBr condition with the sunlight, twice Ag plus Br2. The above reactions are used in a black and white photography. What forms of energy is causing this decomposition reaction? We have seen that decomposition reactions requires energy either in the form of heat, light or electricity for breaking down the reactant. The reaction in which energy is absorbed are known as endothermic reaction. So remember this point, student. Reaction in which energy is absorbed are known as endothermic reaction. Carry out the following activities. Take about 2 gram of barium hydroxide in test tube. Add 1 gram of ammonium chloride and mix with the help of glass rod. Touch the bottom of test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? 1.2.3 Displacement reaction. Activity 1.9. Take 3 iron nails and clean them by rubbing with the sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. The 2 iron nail with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Figure 1.8. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solution in test tubes A and B. Also compare the color of iron nails dipped in the copper sulfate solution with the one kept aside. Iron nails and copper sulfate solution compared before and after given in the two diagrams. Why does the iron nail become brownish in color and blue color of copper sulfate solution fade? The following chemical reaction takes place in this activity. Fe plus CuSO4 reaction takes place FeSO4 plus Cu. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Other example of displacement reaction, Zn zinc plus CuSO4 reaction takes place ZnSO4 plus Cu. Pb plus CuCl2 reaction takes place PbCl2 plus Cu. Zinc and lead are more reactive element than copper. They displace copper from its compound. 1.2.4 Double displacement reaction. Activity 1.10. Take about 3 ml of sodium sulfate solution in test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions. What do you observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance is known as precipitate. Any reaction that produces a precipitate can be called as precipitation reaction. Remember this point. Any reaction that produces precipitate can be called as precipitate reaction. And what is precipitate? Precipitate is insoluble substances form. Na2SO4 plus BaCl2 reaction takes place BaSO4 plus twice NaCl. What causes this? The white precipitate of BaSO4 is formed by the reaction of SO2 and Ba2+. The other product formed in sodium chloride which remain in the solution. Such reaction in which there is an exchange of ion between the reactants are called double displacement reaction. Remember this point also. Reaction in which there is an exchange of ions between the reactants are called double displacement reactions. 1.2.5 Oxidation and reduction. Activity 1.11. Heat the china dish containing about 1 gram of copper powder. What do you observe? The surface of copper powder becomes coated with the black copper oxide. Why has this black substance formed? This is because oxygen is added to the copper and copper oxide is formed. Twice Cu plus O2 reaction takes place with condition of heat gives rise to 2CuO. If hydrogen gas is passed over this heated material CuO, the black coating on the surface turns brown and reverse the reaction takes place and copper is obtained. CuO plus H2 reaction takes place with condition of heat Cu plus H2O. If the substance gains oxygen during the reaction, it is said to be oxidized. If a substance loses oxygen during the reaction, it is said to be reduced. During this reaction, the copper oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxide while other get reduced during the reaction. Such reaction called oxidation reduction reaction or redox reaction. CuO plus H2 gives rise to Cu plus H2O. In this reaction, carbon is oxidized to CO and ZNO is reduced with the Zn, and in reaction, HCl is oxidized to Cl2 whereas MnO2 is reduced to MnCl2. The reactions where ZnO plus C gives rise to Zn plus CO. MnO2 plus 4HCl gives rise to MnCl2 plus twice H2O plus Cl2. From the above example, we can say that if a substance gains oxygen or loses hydrogen during reaction, it is oxidized. If a substance loses oxygen or gain hydrogen during reaction, it is reduced. Have you observed the effect of oxidation reaction in everyday life? 3.1.1 Corrosion. You must have observed that iron articles are shining when new but get coated with the reddish brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of the coating formed on the copper and silver? When a metal is attacked by substance around it such as moisture, acid, etc., it is said to corrode, and this process is called corrosion. The black coating on a silver and green coating on a copper are other example of corrosion. Corrosion causes damages to the car bodies, bridge, iron railings, ships, and to all the objects made up of metals, especially those of iron. Corrosion of iron is a serious problem every year. An enormous amount of money is spent to replace the damages of iron. You will learn more about corrosion in chapter 3. 1.3.2 Rancidity. Have you ever tasted or smelled the fat or oil containing food material left for a long time? When fats and oil are oxidized, they become rancid and their smell and taste change. Usually substance which prevents oxidation, that is antioxidants, are added to the foods containing fats and oil. Keeping food in airtight containers help to slow down oxidation. Do you know that chips manufacturer uses flush bags of chips with the gas such as nitrogen to prevent the chip from getting oxidized? What you have learned? A complete chemical equation represents the reactant, product, and their physical state symbolically. A chemical equation is balanced so that the number of atoms of each type involved in chemical reactions are the same on the reactant and product side of the equation. Equation must always be balanced. In combination reaction, two or more substances combine to form a new single substance. Decomposition reaction are opposite to combination reaction. In decomposition reaction, a single substance decomposes to give rise to two or more substances. Reaction in which heat is given out along with the products are called exothermic reaction. Reaction in which energy is absorbed are known as endothermic reactions. When an element displaces another element from its compound, a displacement reactions occur. Two different atoms or groups of atoms, that is ions, are exchanged in double displacement reactions. Precipitation reaction produces insoluble salt. Reaction also involve the gain or loss of oxygen or hydrogen by substances. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is the loss of oxygen or gains of hydrogen. So student, we have completed here our first chapter, class 10, that is chemical reaction and equation. We hope you enjoy listening, and we simply say that please subscribe our channel Krishna Foundation, and also make the like and share our listening audio library. Thank you for listening. Good day.